Hi everyone, my name is Philip. I'm a freshman at Northwood High School and I've been with the IF Research Lab for about 2 years now. Today I'm very excited to give a presentation on a basic introduction to artificial neural networks and its applications. So before I jump into the presentation, let's take a moment to understand what neural networks even are. Neural networks are a type of machine learning algorithm that are modeled after the structure of the human brain. They consist of layers of artificial neurons that are connected to each other and process data through these connections. Each neuron takes an input, processes it, and produces an output, which is then used to adjust the weights. So first off, let's talk about the functionality of neural networks, and more specifically, what are the fundamental components of a neural network? Because neural networks are machine learning algorithms, they learn from data and are insanely fast prediction machines. They are designed to learn patterns in data by using a layered structure of artificial neurons, which are connected by weighted links. On the screen here, we can see a basic structure of neural networks, and it doesn't have many layers, so it should be easy to follow. So first, the data is fed into the input layer, which is then processed by the hidden layers. The hidden layers process the data and produce an output, which is then compared to the expected output. The difference between the expected output and the actual output, so what we thought the program would do and what the program actually did, is used to adjust the weights of the connections between the neurons. You see those lines over there. Those are the connections, and we're adjusting the weights between them. When adjusting the weights, the next time the network makes a prediction, it will be more accurate. So now that I've explained the basic structure of a neural networks, so how input layers receive data, hidden layers process data, output layers output the data, of course, and then that output is measured with different metrics to adjust the weights. Weights are the components that control how much influence an input has on its output. So by adjusting the weights, we can make greater predictions and more accurate predictions for the neural network. So now that I explained the basic structure, I'll be talking about training neural networks and the amazing machine learning tool called backpropagation. To understand how to train neural networks, you have to first understand what training a neural network even means. The process I covered earlier about input layers receiving data and output layers being used to adjust weights is the basic process of training a neural network. Training a neural network is used to make neural networks more faster, more reliant, and more accurate. In order to train a neural network using backpropagation, we start by feeding it some input data such as an image or a sequence of numbers. The network then makes a prediction based on that input data, but it's likely to be incorrect at first. To help the network learn from its mistakes and make better predictions in the future, we need to provide it with some feedback. Specifically, we need to tell the network how far off its prediction was from the correct answer. These are called the error and loss metrics. Backpropagation works by calculating the gradient of the error with respect to each of the weights in the network. Yeah, that sounds a bit complicated, but let's go through it together. The gradient tells us how much the error would change if we made a small adjustment to the weights. By following the gradient, we can adjust the weights in a way that reduces the error, making the network's predictions even more accurate. We repeat this process over and over, feeding the network with more and more data and adjusting the weights until the network can make accurate predictions on new unseen data. You can think of backpropagation as like a coach teaching his athletes to run faster. At first, the athletes may not be as fast because they lack good running form, their breath control is out of place, and their stride isn't sufficient. But as they train, coaches will give athletes tips to improve and correct different aspects of their running until they are able to compete at meets. It's the exact same with training a neural network. As backpropagation, like the coach, helps correct the predictions, or in the example, the running form, which helps it make better predictions in the future with new data, just how athletes can compete in unfamiliar environments. Correlate new data with unfamiliar environments. In this diagram, we can see a basic example of backpropagation. So the diagram tells us to first sample a batch of data, which is the same thing as feeding like an image or sequence of numbers into the input layers. Next, it tells us to forward it through the network to get predictions. This is the same thing as processing the data through the hidden layers. You see the middle yellow lines. In step 3, it tells us to backpropagate the errors, which is the same thing as providing what I talked about earlier, the error and loss metrics, so that in step 4, we can update the weights to allow the neural network to make better predictions. So now that we know what the basic structure of a neural network is and how it works, let's talk about its applications, advantages, and disadvantages. So how are neural networks being used in our society today, and what are its main disadvantages and advantages? Neural networks have thousands of applications in various fields, and it will take hours to list all of them. Some of these applications include image recognition, natural language processing models, self-driving cars, object identification, and language translation. Even ChatGPT, the incredibly popular language model, uses transformer models, which is a form of neural network that processes text and generalizes it on a large scale. These are all wonderful applications and great advantages to neural networks, but what are its disadvantages? While neural networks may have many advantages and have been successful in many applications, they have 4 main disadvantages that should be considered. First off, they require large amounts of data. Neural networks require large amounts of data to train effectively, and without enough data, the network may have numerous complications, resulting in poor performance on new unseen data. Next, they require significant computing power. Neural networks can be computationally expensive to train, especially for large, complex problems. In my own experience, my 1660 Ti NVIDIA graphics card, I know, big numbers, it wasn't able to sample a batch of data through a complex neural network, just to give you a scale of how computationally expensive these neural networks can be to produce. The third is a lack of transparency. Neural networks are often referred to as black boxes because it can be difficult to understand how they are making their predictions. This lack of transparency can make it difficult to identify and correct errors in the network. The fourth and final disadvantage is how neural networks are vulnerable to adversarial attacks. Neural networks can be vulnerable to adversarial attacks in which small changes to the network can cause mass destruction to every single part of the system. This can be a problem in applications such as image recognition, where if we change a small part of an image, maybe take out 3 or 4 pixels, these adversarial attacks can cause the images or the neural network to misclassify the image. It's important to consider these disadvantages when deciding whether or not to use a neural network for a certain application. While they can be very powerful tools, they are not always the best solution for every single problem. So last but not least, what is the future of neural networks? The future of neural networks is bright as they continue to be an active area of research and development. Here are some key trends and directions for the future of neural networks. Neural networks have been around for several decades, but it's only in recent years that they have become an essential component in deep learning. With an increasing amount of large data sets and computational power, deep learning techniques that rely on neural networks have achieved unprecedented performances in various tasks, such as image recognition, speech recognition, language translation, and gameplay. The exciting trend in the future of neural networks is the increasing popularity of reinforcement learning and generative AI. It's an exciting time for the field of neural networks as researchers and developers are increasingly incorporating reinforcement learning and generative AI into their own work. Reinforcement learning, which involves training models based off a reward-based system, has shown great promise in areas such as robotics and gameplay. Generative AI, on the other hand, involves training models that can generate new images, new music, new text. One of the most exciting examples of generative AI is the ChatGPT language model, which has made a significant impact on the field of natural language processing. ChatGPT is a powerful tool that can generate coherent text responses to complex or simple prompts, making it a useful tool for tasks such as language translation, summarization, and even creative writing. In conclusion, neural networks are a powerful type of artificial intelligence that can learn from data and make new predictions based on its complex layer system, what I talked about earlier: inputs, hidden layers, outputs, and weights. They have many applications in various fields and are constantly improving and evolving. However, it's important to carefully consider the advantages and disadvantages of neural networks, and to choose the right type of network and algorithm for the job. Thank you for listening to this presentation on neural networks. If you have any questions or comments or concerns, please feel free to ask. Thank you.
Thank you for your interesting presentation. It is very interesting that you could explain neural networks so well because for me, throughout my 5 years of PhD, it was still difficult to understand fully what is the neural network. So it is amazing. Thank you for your great presentation. So any question from the audience? Yeah.
So is there any way to speed up the training? So for example, is it possible to have multiple computers are getting their data at the same time and then integrate the results into the one neural network later?
I haven't had any experience with like multiple computers, but I've heard Sam, he has been training like data of his own, and then he said he had purchased more than like tens of thousands of dollars toward computers, like multiple NVIDIA high processing graphics cards. So of course it's possible to speed up the training process. As you have more computational power, it equates to faster training and more efficient training.
Yeah, just I think you can just say whether this AI is good or not is if it's predicting well or not, right? And how can I select the data to train it to make a better prediction?
So what I talked about earlier, let me go back to the slide. Are you talking about like how you can train data?
Yeah, because there are tons of data, if just an abstract way, but maybe a lot of data, it requires a lot of money to spend, but too small amount of the data doesn't make that the result is not matched to the prediction well. So how can I decide how much data I need to just train, or what kind of quality data, and how can I just choose to make a better prediction?
So training data basically revolves around like the types of programs and what type of application you're trying to like pursue. For example, if we have large data sets, we need large computational power, and if we have small data sets, you only need small amounts of computational power. If we have small data and even less computational power, it's very complicated, as sometimes a neural network may do something called overfitting, which is memorizing its own data, which is based off like inaccuracies. And overfitting leads to misleading predictions in new unseen data. So yeah, it matters. The programs I use, Python, Keras, PyTorch, all those are great programs to help you identify what type of resources you need and what the amount of data you need. Yeah.
It seems like you know a lot about this topic. Like, how has like neural networks like affected like your own research and kind of like your own projects?
So neural networks that's all I've been focusing on for like the past few months. I worked with something called the MNIST dataset, you might know. It's a data set of thousands and thousands of computer-generated images of numbers. So, but they're different. The pixels are arranged in different ways, but they still resemble numbers. So let's say a 7 is drawn like this, but a 7 can also be drawn in the same way, or we can recognize a 7 if it's slanted a bit to the right or slanted a bit to the left. Computers aren't naturally able to process these, like able to recognize these like differences. They only like have one set of instructions and they follow those instructions. But neural networks are the tools that help us, now I'm talking about image recognition. It helps us make better predictions on the different types of images. For example, let's say I was talking about the 7 example. Neural networks would help us recognize the different pixels because of those weights, it would help us calculate, or recognize the images. Yeah.
Yeah, okay, thank you. So because of time, I know that you should have a lot of more questions, but because of time, I think we can take just one more question, and then we can go to the next page.
You talk about lack of transparency in neural networks. Is it, by lack of transparency, do you mean the fact that people are unaware that a system is using neural networks, or do you mean we don't understand why neural networks need accreditation?
Both. Those are both disadvantages, but the one I was talking about was as like lack of transparency to the person who is using the neural networks. So because neural networks are so efficient, they're so complex, we can't find like the small errors that have like massive effects to our neural networks. So the weights, how backpropagation works, the black boxes I'm referring to is, how the inaccuracy in the system itself.
Okay, thank you so much. I believe that the level of questions and the answer that I hear from here is just kind of PhD dissertation. So, congratulations, you passed your dissertation. Okay, thank you so much. Our next question